Now let's begin with the exercise. For this, we will use QGIS 3.2 that I have already discussed. So we are now opening the QGIS. So we can use a new project, but I have a similar kind of project. So I am using in this project to prepare the map here. So I will prepare a new map. As I have talked previously, we will be using this data, location data and the respective depth data that was collected using sonar in the lake will be implemented to prepare the bathymetry map in this study. So this is the Excel CSV file. We will importing this into the QGIS interface and preparing a interpolation map. So let's do it. For this we have to import a text delimited layer from here. Now we will move towards this is the point which I have shown sometime before. This is the depth data. So we will open this and we will put the x field as a longitude and y as a latitude, and we will put z values as a depth and then add this to the map. So these are our depth point. So where this point falls we can know by adding a base map on this. I'm going to add a Google satellite hybrid image here so that we can know the boundary of the lake. So this is Khaste Lake somewhere in Nepal. So this is the bathymetry data and we will using this. So first of all, I want to save this layer as a save file layer because it is in the Excel format. So I want to save this as a save file format at first. So I will save this as a depth data. I will keep the uh, coordinate reference system as this UTM zone 44, which is used for the western part of Nepal. So I will save this. So this is our data in zip file format. I will remove this CSV file from here. Now we will split these depth data into train data and test data so that we will use train data for modeling purpose or the preparing the interpolation map, and we will use the test data for the validation purpose. So I have already said that we will use the RMSE value. So RMSE value will be calculated using that test data. So first of all we will split this data into two sets. For that we will use the random selection tool, these two, and we will input uh, depth data and we will consider percentage of feature, and we are going to use 30% of the data as our test data. So it will select random 30% of the points from these all points as a test data. Now we will save these points, save selected feature as test data. So I will save this, and remaining data I will use the invert feature selection tool from here. So these are another 70% of the data selected here, and I will save them as a train data here. Now these are test and train data, both selected, both are here into the different layers. Now we can use train data for the interpolation purpose. For this, we have to use the processing toolbox here, and we will found the interpolation, and we will use we have the vector data as a point shape file, so we will use this saga tool. No, sorry, we will be using this grass tool, b.soft.rst, no, idw. So we will use this tool, and we will use train data, and we will keep this value. This is the number of interpolation points, means how many number of the neighboring point will be used or will be considered for using the idw method to interpolate the next unknown value. This we can put the default. We can put this values power parameter as default, and we have to use here the depth data, so that it will use the depth column for the interpolation purpose. So we can select the extent. For that, we have to add here another layer, which is the lake outside boundary. So I will add the lake boundary file from here. So there is a lake boundary. I will open this and add here. So we can select the extent, calculate from layer, and there is lake layer, and we can use the pixel value as per requirement. Here I'm going to use lake is in a small size. I think it is not very much big, so I will be using 5 meter as cell size here, and all these things will be kept by default, and I will run the code. So here we can see the interpolated map prepared. Now we can clip this layer, but first we will put this in this color format. So this is the bathymetric map, interpolated map prepared, and we will use a lake map here. We can make this visually something more attractive. We will clip this feature within this range by doing this. So this is the lake area only, and this is the bathymetric map. So these are the training data set, these are test data. As I have already said, we will use these test data for validation purpose. So if we look in the attribute table of this subset, there